Now the recording has started. Perfect. All right. So starting at the top, Software Package Data Exchange License Identifier, MIT license, common open source license. And anything that has these backslashes or a backslash and an asterisk like this, it instructs the compiler to just ignore it. Just keep the text as a comment. So it's commenting out, like, you know, that this is just for video demonstration. And it's meant to, you know, give some context on why things are coded the way they are, maybe, you know, what this contract does, you know, who should deploy it, ways people might alter it, that sort of thing. And then down here, it's used to describe what each function does, what each parameter is meant to accomplish. And this is just good practice to kind of inform anyone who is using your code or is using the smart contract on chain and is able to view the code, the verified code, how this is intended to be interacted with and used, that sort of thing. So from there, we'll go down to this word here, pragma, which I was not familiar with before I started learning Solidity. Apparently it's from C or C++, but it basically instructs the compiler, which is a program which takes the Solidity code and compiles it down to something that can be actually sent to the Ethereum virtual machine and used as a smart contract, which we'll be doing. So this is instructing the compiler to use the Solidity compiler version 0.8.6. And show you that if I can expand this. So this is the compiler panel in Remix. This is the version, and you know, if all these historical versions, it'll automatically go to the one that's appropriate for this file since we've declared it here. And you know, once this code is complete, you hit compile so that it's ready to deploy. And if this has any errors, I'm going to pull my hair out. Nope, we're all good. Okay. So I'm gonna just move on down to constructor before we deploy though. So after some comments here to kind of give context on what this smart contract does and how you're supposed to interact with it or use it, you first declare any interfaces that you need to use for this. And so what an interface is, it's, you know, I should also stop here and say that every explanation I give in this walkthrough is going to be, it's going to have some level of technical incorrectness because I learned most of this myself. So, and I don't have a ton of programming experience before it. So I may describe some things that are maybe not fully technically correct, but they'll get you there. So this interface is used to take this smart contract code that we're deploying and have it interface into a different smart contract that's already deployed on the blockchain somewhere. And the reason we need this one is that this escrow contract is for stablecoin tokens. And so what's happening is payment is being sent to the escrow contract, held by the contract, and then remitted to the seller, you know, if it closes appropriately, in tokens. And tokens are not something that are just a native asset to the blockchain. They are actually the product of their own smart contract. And that smart contract basically just takes all the addresses, or it just shows what the balance of a given address is in those tokens, which is a confusing concept. So I don't want to dwell on it too much since this is sort of a beginner walkthrough. But the point is that a stablecoin token, to use it in a smart contract, you actually need to interact with the stablecoin's address, that contract address. So that's what this interface does. And how we declare that interface, I'll get to shortly. So after you've declared any interfaces that you need to in order for your contract to work or do what it needs to do, then you declare your actual contract. And so I just called this one escrow stablecoin, open bracket, close bracket is all the way at the end. So the first thing you want to do is you want to declare all of the variables and mappings you're going to use in here. And so this will give me a chance to kind of explain what these are. These are just the declarations of what the variables are named, and maybe any properties they have, like if they're payable or if they're publicly viewable. But they're not assigned any values up here yet. You can, but I didn't, because they'll get assigned in this constructor or down in a different function. So the escrow address is going to be the blockchain address of this contract after it's deployed. There's going to be a buyer, there's going to be a seller, there's going to be an address for the stablecoin token. There's going to be a deposit, which is going to be an amount. It's going to be a positive number, so it's an unsigned integer. Same thing with the effective time and the expiration time of the escrow, which we'll get to later. But these are some important things here. When you're using tokens, you don't use decimals in Solidity. There's no floating point numbers, so you always have to use whole numbers. And the way that this is approached is basically a lot of the token implementations just add a bunch of decimal places or a bunch of zeros to their amounts. So what we're going to actually have to do here is take our deposit amount that we want to use and add 18 zeros to it to kind of get around that issue. And that's a not the best user experience, but in practicality, the way that would be addressed is whatever website would be set up to interact with this smart contract or other front end, you would just abstract that away by saying a user enters 1,000, but when it's submitted to the Solidity contract, it adds 18 zeros to it without making the user do that. And the way that time is approached is actually in Unix time. And Unix time is in seconds, starting at Wednesday, December 31st, 1969. So it's a rather high number in seconds, but there's a native detail to blocks in Ethereum that you can read what the time is in Unix time according to what block number you're looking at. So we're going to use that for our sort of expiry of this escrow contract. And then some Boolean values, which start out as false unless declared that they're true. So when these variables are declared, they're all false. Seller hasn't approved yet, buyer hasn't approved yet, it's not expired yet, not closed yet. This is a declaration of this interface up here and how we're going to feed the token contract into it, which we obviously haven't done yet because we have to give it the address. Description of the deal or the escrow just for memorialization, and then a mapping, which is a bit of a confusing concept, but it's basically a key pair where you can take an address, assign it to a Boolean, a true, false. And so this one is to say whether an address is a party to this deal. And so buyer and seller and this escrow address will all be mapped to true because they are parties to this deal. Events we'll get to at the end. And this modifier we'll get to a little bit later because modifiers are a bit confusing as well. But let's start out with the constructor now that we're like 20 minutes in and I've already been rambling at you. So the constructor is a function which is called upon deployment of the contract. So after the contract is deployed, this is no longer usable. So this is a one-time only. And this is a good way to initiate the terms of the smart contract by the terms of the deal. So, you can look at the comments here. There's some instructions on how to do this. The buyer initiates escrow with a string description of the deal, the deposit amount in USD. Actually, this is incorrect. It's going to be USD times 10 to the 18th for 18 zeros, as I mentioned before. The address of the stablecoin token, so the contract address, and I'll show you how to find that. Seconds until expiry, and again, I did seconds because of this Unix time thing, but that's something you can abstract on the front end. And then you're going to the buyer is going to designate the address of the ultimate recipient, which should be the seller if all goes according to plan. And that's also explained here in this sort of parameter comment explanation. So this is already compiled. I already hit compile before. I'll do it again. Why not? And didn't mess anything up in the meantime. So now that we've compiled, and if there were any errors, they would pop up right here in red, and they would give you the line number and say, you can't do that. And maybe give you a bit of an explanation, but not always quite enough to know how to fix it. But it would have popped up here. Then we're going to go to the next window, which is deploy and run transactions. So because we're deploying this on-chain onto the Rinkeby testnet of Ethereum, we're going to make sure that our MetaMask is connected. This is, again, this is the buyer wallet, and this is this is the address from which we will be deploying this contract. So you need to change the environment up here to injected Web3, because this is an injected Web3 extension. Shows that we're on the Rinkeby testnet. This is the same address as the seller address up here, 0xB7F4, and then a bunch of other numbers, 0xB7F. Gas limit, you can just leave that. The value is going to be 0 way. You don't need to send any additional ether because this is well, for a couple reasons. This is a token escrow, not an ether escrow, and also the buyer doesn't send the deposit right at the beginning, and I'll explain why in a moment. So this is the big red deploy button. And when you drop down this menu here, you'll see you have each parameter to the constructor that I went through before, and you'll just add in the details here. So for a description, I'll just say it's a test demo or whatever. For the deposit amount, let's use, so for the stablecoin, we're going to use DAI. Let's use 90,000. How about that? And again, I have to add 18 zeros, so just bear with me here. Thank you for no one interrupting my count. And so then the buyer is, again, deploying this contract. They need to put in what the seller's address here, and because I'm doing this myself, I'm gonna just put in this address for the seller. Copies the address. Buyer. And paste it in there. And here we need the stablecoin address. So again, we're going to use testnet DAI, which is on mainnet it is intended to be pegged to the US dollar. On testnet, it's testnet. So whatever the thing is from whose line is it anyway, points don't matter. So we need to look up the contract address of this token. So we can go to these 3 dots here, view on Etherscan, and it'll bring up the page for this token with the contract address right here. So I just clicked on it. This is the contract address for this testnet DAI. We're going to copy it, and we're going to go back to Remix. We're going to drop it right in here. And for seconds until expiration, I don't really want this to expire while I'm demonstrating, so I'm just going to say a lot of seconds. Okay. We're gonna make it damn sure this does not expire. All right, so now we're going to transact, and this is going to deploy this entire file, this smart contract to the Rinkeby testnet chain. So I get a pop-up from MetaMask saying my buyer address is trying to deploy this contract. Here's the gas fee. We have to pay gas in testnet ETH in order to broadcast it and deploy it on chain. It's an estimation much lower, obviously, than mainnet would be, and I'm going to confirm it. So now down here, it's going to say create. Okay, yes, I know. Creation of the escrow stablecoin is pending. Oh, it's already done. It already deployed. Here's some more information. I know this looks like gibberish to a lot of you, but it's just a little summary. And if you wanted to follow it from here, this is your assets. This is your activity page for this address in MetaMask. You could click this, view on Etherscan, and you can see that this contract has been successfully created, deployed from the buyer address. And here's a transaction, all kinds of useful information here. So what's next? We go back to Remix, and we can minimize this now because we're done with the constructor. And now it has a little interface here that shows the deployed contracts. So this is the contract that was just deployed. And so you can open the details here, and it gives you the address at which it was deployed. So that should correspond to up here, contract 0xBC, 0xBC. And so what this does is it gives you an interface to all the functions and sort of ways you can interact with the smart contract. And the reason why some are in orange and some are in blue, it shows that the ones in blue do not require gas to interact with them. So they're view only or some other mechanism where you just need to read the data from the function or from the contract. Whereas the orange ones require gas because you actually need to change the state, or you need to access some data which is not view only. So you are, instead of reading, you are writing here, and writing costs gas. So, and I'll show you how that is demonstrated in the functions. But first, I'm just going to pause for a second to see if anyone has any questions, and also get a drink because I've been speaking for 30 straight minutes. Any questions?
Yeah, Eric, this is Noah. Why is the interface outside of the contract?
The interface to the ERC20 or the interface over here?
Yeah, sorry, the interface to the ERC20.
Yes, so this is what this means is it's the contract that we've deployed needs an interface to a separate contract that has already been deployed. And so why it's separate is that this is declared up here as the sort of functions that this smart contract is going to access by approving some tokens to be sent to it, checking the balance of an address, transferring tokens, transferring from an address. So you can see here that this interface is declared as this. This is kind of confusing. Maybe I should have made these different, but this is a lowercase variable. This variable, you can see right here that what we've done here is we've pasted in this stablecoin address, which you might remember from the deployment. I copied from the testnet die, put it in the constructor, and then hit deploy. That stablecoin address, what happened was in the code of the constructor, what you inputted was assigned to the stablecoin variable, which we initially declared up here. And it was declared as the address which is being interfaced through this ERC20. So what this means now is later on in different functions, when we, for example, have a transfer of tokens, it's saying go to this address, this ERC20 token address, and from that, using the function at that address, which is declared at that address, transfer tokens from buyer to this address in the amount of deposit. So this is separate because it already exists at a different address on chain, this address right here. So hope that answers the question.
Yeah, it does. Thanks. So as long as it's in the same file, the contract can interact with it, I guess, or at least reference it.
Yeah, what's necessary is you need to input the exact blockchain address that the interface is accessing, and we did that in the constructor. So the interface is just like a common form to say read these functions from that address, and then if they're called somewhere in this smart contract, use them as they're defined in the other smart contract. And this is probably one of those instances where my technical explanation is not great, but hopefully it's at least somewhat useful.
No, it makes sense. Makes sense. Thanks.
Sure.
Eric,
and yep, go ahead.
Sorry, this is Olta. I mean, I'm brand new to this, so hopefully this is not going to sound stupid. But you mentioned that the event and the modifier is going to be, did you mean like that is going to be explained later on, or that is not supposed to happen when you start sort of drafting everything here?
Oh,
Does
no,
it make sense?
good question.
Yeah.
Yeah, good question. I just meant I would explain them later on because it's just like a little confusing and I don't want to inundate with too much.
Okay, but usually it has to happen, I mean, when you start sort of drafting everything for the contract, right?
Yes. So once you deploy, this is all done. Like if I were to just delete a bunch of this right now, it would not have any effect on the smart contract because that contract is on chain. So, you know, it's all done. You have to code it all at the same time, and then it gets compiled. And once it's compiled and deployed, you're done. So yeah, that was just me saying I'll come back to it because it's a little bit of a confusing concept. But
thank you.
But actually, this is a good point. I should go through the code and the constructor itself, actually. So this is so again, this was already called. This was called when we deployed the contract. So this is already done. But what this code means here, we have a require statement, which requires some condition to be true in order for the rest of the function to be actioned. So what this is saying is the address that I submitted as seller cannot be the same, or is not equal to the message sender. And so the message sender is a global variable in Ethereum. It's not something you need to define. It's just, it has its own, it has a global meaning to it. And what value this carries is the address which sent the message. I guess that's a little circular, but in this case, the address which sent the deployment or called the constructor function, which was the buyer, because they initiated the escrow by deploying the contract. And so obviously you don't want the seller's address to be the same as the buyer, otherwise this would have no purpose. And so this has to be true in order for this to work. And what this is the error message that would have spit out if I had the same address here. It would have said designate a different party, you know, you idiot. And then further down, this is really just assigning these variables for the purposes of the smart contract. So the message sender, or the person that deployed the address that deployed the contract, is the buyer. The deposit amount that was submitted, that's the unsigned integer deposit variable. The escrow address variable is, and this is another global variable in Solidity, it's this address, basically, because it's, you know, you're constructing the contract, and that's this address. This is the stablecoin address. This is the interface that I just talked about, the description of the deal, seller address, and then these are the mappings that I described earlier, which are going to map each of these addresses, the message sender or buyer, the seller, and the escrow smart contract address, all is true. So they're all parties. And the reason why that's important, as I mentioned here, is that you want to designate which addresses are parties, because in some of these functions, a few of these, you only want these functions to be called by the parties to the deal. And so one of the sort of sleekest ways to do that, and sort of gas efficient ways to do that, is to create a modifier which modifies functions. You give it a name. I decided to call it restricted. And it basically says that, you know, if you use the restricted modifier, such as the deposit and escrow function, you can see right here, you have to be a party to this transaction. So if you're using an address that's not a party to this deal, and you try and call, you know, designate seller or deposit and escrow, it's going to spit an error message at you that says this can only be called by a party to the deal. And so that's what a modifier does. This, I can't even begin to explain what this means or why this needs to be here. It's been explained to me a million times, but I'm just going to have to punt on it. But that's basically how a modifier works. And it's a sleek way to sort of restrict who can call a function, basically. So that's the mappings. And then we've set our expiration time for this contract by the seconds until expiration. I entered like 5 trillion or whatever seconds. And that's added to the timestamp of the block in which this smart contract was deployed. So another global variable in Solidity, it takes the block, and then some information about the block in which it's in. In this case, it's the timestamp, and that's again in Unix time. So that's in seconds. So it's basically the current time plus the amount of time until expiration gives you the expiration time. All right. So let's take a look at some of these functions. So you can use check escrow. I'm just going to scroll down to the view ones because they're a little simpler. You can use check escrow to see if any to see the balance of the escrow address in tokens in these ERC20 DAI testnet tokens. And so this function is declared as external, which means that and it has to be called by an external address rather than another another function inside of this smart contract. It's also given the restricted modifier, which says not only does it have to be called by an external address, it can only be called by a party to this transaction. The readability, it's a view. So basically, this is permitting you to view information, but not to change the state of the chain or to write information, and to kind of simplify that a little bit. And then when you call this function, it's going to return an unsigned integer. And it's 256 because it's 256 bytes of information is the, or sorry, it's, yeah, what is, it's 2. And so uint 256 is an unsigned integer, and the maximum value is, I believe, 2 to the 256th power minus 1, which is something like more than the number of atoms in the universe or something insane like that. So yeah, so this function is going to return a positive number basically, or 0. And what in fact it's going to return is the balance of this address. So we can, since I'm still in the seller, or sorry, buyer address, I can check the balance. Should be 0, and it is 0 because I have not set the deposit yet. Can check this for the token address. There it is. Good stuff. Okay, so unfortunately there's a bit of a idiosyncrasy here with ERC20 tokens that is going to throw the sort of beginners, but just bear with me here for a second, and that's what this comment is all about. So in order to allow allow an address to transfer tokens from another address, you have to approve the address that is doing the transferring to do that in the amount of the tokens that are to be transferred. But you can't do that in this smart contract because you have to approve the token address. So what this is saying is you have to go to the ERC20 smart contract and approve the address of this deployed smart contract for the deposit amount so it can transfer that amount. So again, I'm sorry for the confusion there, but we have to go to the ERC20 contract. This is the stablecoin that we're using. And we're going to, as the buyer, which I hopefully still am, we're going to take the address of this smart contract that we've deployed back in the stablecoin address. We're going to go over here to contract. We're going to write to it. And if this looks complex and sort of like a terrible user interface, it's because this is all backend. So, you know, if I were a front-end developer or a full stack and I were to set up a website and kind of abstract all this complexity away, you wouldn't have to deal with this. But since we're dealing just with Solidity, just on-chain blockchain stuff, we're interacting directly with smart contracts. We're not dealing with websites. We're going straight through Etherscan here. So I got to connect my wallet. So now we've connected to the buyer address, and we're here in the write contract options. And these are the functions which require gas in the stablecoin token contract. So what we need to do, and you know, if I wanted to just transfer tokens, I could say, you know, here's the recipient address in this amount, and then I'd hit write, and it would send tokens from my address to this recipient. What we're doing here is we're approving the smart escrow contract address. in the amount of 90,000. So I did right. We're going to add 18 zeros. And we're going to write. So what this is going to do is from my buyer address, it's going to write a transaction to interacting with this token stablecoin smart contract, approving the escrow contract to be able to transfer a certain number of tokens from the buyer's address. And again, it's just an idiosyncrasy of the stablecoins that is understandably confusing. And this is a link to just see when the transaction goes through. This might take a second, so I'll come back to it. So the next step in this escrow, it's been deployed. Obviously, the next step is for the buyer to actually deposit the deposit amount, the purchase price. And so once this approved transaction goes through, I will do that. Yep, here we go. So this is the buyer address, interacted with the stablecoin address and approved it to transfer tokens. And so it's a success. It's gone through. So now what I'm going to do is I'm going to call this deposit and escrow function. And the code for that is up here. And so what this is doing, again, it's a public. Actually, I could have made this external instead of public. But we'll leave it as public for now, which says anyone can interact with this internally or externally. But wait, just kidding. There's a modifier in here that says only a party to this deal, only someone who's been mapped as a party can call this function. And what this is going to return is a Boolean. You know, if it succeeds, it'll return true. And it's going to return a number. So this is going to return the balance of the escrow address after sending. This is kind of unnecessary because, well, I guess this modifier is unnecessary. If I want only the buyer to be the person calling this function, I don't really need this as well, but it doesn't matter. So, so great. So now I'm gonna call this to deposit the tokens in escrow. And so actually, hold on, just gonna check my balance before. So I have 998,000 DAI in the buyer account. Seller account, I have 10. So great, let's do this. So this will say my transaction is pending. Great, so it looks like it's succeeded. Now we can actually go to it. This is, no, I'll skip that actually. So the deposit function has succeeded. So tokens have been transferred from my buyer address to the smart contract escrow address, and the amount was the deposit, the 90,000. And so now I can check escrow, and it should say 90,000 plus 18 zeros. Yes, good. So this shows that there are 90,000 DAI in the smart contract. And here's the, is this the, yeah, this is the smart contract address. So this is the transaction that has the stablecoins going in. And there they are, 90,000 DAI. Okay, so now we have money in escrow. Buyer is ready to roll. You know, ostensibly all of their conditions precedent are satisfied. They're ready to go. Seller, on the other hand, is also getting their stuff together. But now they see, oh, the money's in escrow. Well, here, we'll switch over to seller. So now I am the seller seeking payment. And again, I only have 10 bucks to my name. So I'm, oh, you know what? I forgot something before I switched to seller, actually. Sorry. So another aspect of this escrow contract, I mentioned this at the beginning, but both parties have to consent that they're ready to close. And so that's this function right here. What that does is it basically just says when both have approved, that closed deal can be called. So all this function does, and again, it's the same as before, external address only can call it, restricted parties returns a string, or letters, numbers, characters, and it signifies that address is ready to close. So it's a simple if-else statement, which is pretty much every programming language has. If the message sender, so the address calling the function, if it's the seller, then change the value of seller approved to true, because this is seller saying they're ready to close, so they approve closing. They'll say seller is ready to close. If the message sender is the buyer, which in this case it is the buyer, it'll say buyer is ready to close, and buyer approved will be true. So I'm calling this function. It has to change state because it has to change this Boolean variable from false to true. So that's why it costs gas. Transaction is pending. By all means, take your time. All right, and we're good. So that went through. Now we're going to switch over to seller. So seller checks escrow, sees that 90 grand is in escrow, and we're ready to go. So in that case, seller's ready to close too. Hit confirm, and because the message sender is now seller approved is going to change to true. That transaction's done. So now both parties are ready to close, and we're just waiting on someone to call close deal. Before I do this, though, I'm just going to touch on the other functions that I ignored in my haste. There's a function here to change the seller's address. If the seller needs to use a different address, or let's say there's a lender, or any reason they need to change their address after the smart contract has been deployed, this function can be called by the buyer or the seller, and you pass a new address here, and provided you get through the require statements here, which says that this address is already seller, so there's nothing to be changed. Same as the constructor, the buyer can also be the seller, or the deal is expired, so it's too late. Then this new seller address is introduced as a party to the transaction, as a true mapping, and the seller variable is changed to this address that was input by the person that called this function right here. So it would be added here, and this would be called. So no need to change seller address. I just skipped that one. Deposit in escrow is how we deposited from the buyer. Return deposit, this is the function that is called internally. So this is called by another one of these functions. It's actually this check if expired function. And what happens is, I'll start here actually. So this function check if expired, it's external, and there's no modifier here. So any address could call this function if they wanted. And what this function does, it's another if else. It checks if the expiration time is less than or equal to the block stamp of the timestamp of the block in which this function was called. So it's saying if the timestamp for this block is equal to or greater than, if the expiration time is less than or equal to the time of the block in which this function was called, this is expired variable is changed to true, and this return deposit function is called. So this calls this. And what that does, it's called internally. What that does is it transfers to the buyer the deposit amount. So if it's expired, buyer gets its deposit back in this construction. So obviously you can code this smart contract to be non-refundable very easily, or you could say it's refundable only before a certain time, or it's refundable only if the moon is gibbous or something. I don't know, whatever. I'll probably do an escrow demonstration with external data later on. But anyway, so that's one internal function, how that works and how the expiry is checked. The expiry is also checked in ready to close, in closed deal, because obviously you don't want the deal to close if it's expired for the same reasons. Yeah. So, and this is how the seller is paid. I'll get to that in a second when the closed deal function is called. So, funds are in escrow. Both parties have consented to closing. We're ready to close. Anyone can call close deal. So, you know, if some unnamed law firm associate is tasked with calling close deal for this escrow function, they can use their own personal address if need be to look up put in the blockchain address for the smart contract, go to Etherscan, find close deal, and hit close. We're going to do it from, I'm just going to do it from my seller contract just for the hell of it. But so we're going to hit close deal. And while that's pending, I'll take you through this here. So this close deal function, obviously you want both seller to have approved and buyer to have approved. Looks like it's already successful. But so you want seller to approve closing, buyer to have approved closing. This is the operator that says both need to be true. This is the error that would pop up if one of these or both of these was false, saying that the parties are not ready to close. And then you have your simple if-else statement. If expiration time is less than or equal to the timestamp of the block in which this function was called, expired is true. Return the deposit to buyer. Emit an event that says the deal was expired, and I'll get to events in a second. Otherwise, you know, if so, this is if the expiration time is less than the timestamp. Otherwise, obviously, the other option is that it is not, so it has not expired. Then we close. So is closed is assigned true. This calls pay seller. So let's look for the pay seller function, which is up here. I should also mention that the functions that are declared as internal like this, they won't show up over here because they can only be called internally by this smart contract. So I, as an external address, can't call them through this interface or through Etherscan like this. So since it hasn't expired, pay seller is called. This transfers the deposit amount to the seller in the tokens, and then it returns true if it's successful, and then the balance of the escrow address, which should be 0. So it said this transaction already succeeded. Let me check escrow. Should be 0. It's 0. Let me check my balance. Should be 90 grand plus 10. There we go. So seller has received payment. And so that means this succeeded. The effective time of the deal is stamped in the information of this this function call. So here, let me expand this a little bit. This is the close deal function you can see right here. From seller address to this contract, this function. Don't need to worry about that. Status is true, execution succeeded. This is how much gas it cost, transaction hash. So these are the logs. I'm not going to get into this, but you can see that in where are we? There we are, close deal. So this event, this deal closed event, has been emitted with the arguments of the Boolean is closed variable, which has now been assigned true. So argument 0. So the first one is true. The second emission is the effective time, which is the timestamp of this block in which the deal was closed. Here are the seconds in Unix time. And so hopefully, wait, why did this go through twice? I don't know why it comes up twice. Probably just me being not great at this. So again, this is the effective time, which is the block timestamp. This is in Unix time. Let's hope it says today, and it does. I'm running out of time here. So there's your effective time of closing for all of your deal documents. Extra points if you put it in Unix time. And so that's your information. And this is all stamped on chain. So this is memorialized on the blockchain. Here's the smart contract escrow address. There's the transaction address for closing, and everything you need to know. And so the last thing I'm going to touch on is this emit event. So what events are is they basically broadcast information for a front end or a webhook to kind of latch onto or communicate with. And so, you know, all of this Solidity code is happening on chain on Ethereum. And if you're using a website to kind of interact with it, the website has no idea what's going on unless it's communicated to in some way. So this event, deal closed, emits the information of whether the deal has been closed, which is true, and the effective time. So if there were a website interface, it would basically say, we're done. Here's the time of closing. You know, check your address. Money's there. And so that's that. That's pretty much everything I wanted to go through on the code side. And you know, the escrow worked. Seller has its money. Buyer is now down 90,000 DAI for whatever they paid for. And so I'll just pause for a second for any other questions before I stop sharing my screen. I can also answer questions afterward. But while I have the code up, please let me know any other questions. Maybe everyone left. That's entirely possible after an hour of this. All right. Well, in that case,
Kadir, I have one small question.
Sure.
Which line is the part which enables this smart contract to interact with MetaMask, for example?
Yeah, great question. So that is this interface right here. So Remix, this browser interactive development environment, you choose your environment. So the one I've chosen is Injected Web 3, and the Injected Web 3 is MetaMask. It's interacting with the chain in that, you know, you have your externally owned account, your address is here, and you can interact with web pages or other things in browser because of MetaMask. So this injects your MetaMask to everything you interact with in this sort of panel here. So that's a great question. And the other thing is, you know, if you're just messing around in Remix, and this is like 95% of how I learned, if you want to just choose this JavaScript virtual machine, I'm not going to switch to it because this will go away, but this is basically instead of using a testnet, it just kind of mimics a blockchain. So you can, and it's very fast because the blocks don't have to be propagated. So you can call functions, do whatever you want, compile, all within this web page, just a virtual machine. So, you know, Remix is great, but that is the connection to MetaMask.
Thank you.
Yep. Anyone else?
Yeah, just a last question on the constructor, Erich. Does every contract have to have a constructor, or, you know, like what if here you just labeled it a function? What effect would that have?
So every contract does need a constructor, but you do not need to pass anything to it. This can be empty. So okay. This can be nothing. You know, this can also be this can all be deleted. And what that would do, if the constructor was completely empty and there was nothing happening here, is basically it would deploy everything else. So all these functions would be deployed, all these variables would be, you know, similarly declared, and everything else would be here. It's just that you wouldn't be able to assign values as the creator of the smart contract. And so another big thing with constructors is that if you have a contract that you want to be ownable by a certain address, that's often done in the constructor to sort of designate that party straight away. But yeah, you can absolutely have an empty constructor, but you do have to have one.
Okay.
And, you know, just my luck, I'm sure there will be a new version of Solidity in like a month or something that just does away with it. So, you know, everything I say is as of version 8.6. So keep that caveat.
Thanks.
Sure. Anyone else? Going?
Hi.
Go ahead.
Sorry. Who goes first?
No, go on, please. I didn't want to.
Oh, thank you. I have a question about gas fees because I mean each time we call some of the functions to write, you've got to pay gas.
Mhm.
So is there a way to set limits on gas fees, like,
Yes.
to prevent people from like mindlessly clicking at a moment where gas fees are spiking?
So, okay, so this is probably going to push on the limit of my technical knowledge. I am not sure how you can do that in a smart contract in the Solidity, but usually the wallet interface has a mechanism for that. And so what that would look like is like, I don't know, okay, I'm just going to send this to this smart contract, whatever. And so like if I were to send like 0.1 ETH, whatever. When you saw this pop up every time I interacted with a function that where you're writing, which costs gas. You can edit the gas fee that you're comfortable with paying. So you can set a maximum, you can set an estimate, and then there are even more options too. You can limit the amount you want to pay, the priority fee, the max. Or sorry, this is the gas limit for what you're calling. This is the max fee you're paying. So there's a lot of things you can customize, but it's at your wallet level. I'm not sure about how you would do that in your smart contract code other than just generally minimizing gas costs. And there are a million ways to do that. Like, for example, external functions cost less gas than public functions. Certain variable types like mappings. So if instead of this mapping, if I were to create a separate variable for each party that says they're a party to the transaction, that costs much more gas than a mapping does. So there's all kinds of tricks for minimizing gas, but I'm not sure how to hard code that in Solidity.
Thank you.
Sure.
I have one more small question. I hope this is not too far-fetched, but if you want to make this smart contract also available for other blockchains and smart contract platforms, is it something you have to code into your smart contract, or how does it work? Do you know?
Yeah, that's another good question. So this the language of the smart contract is Solidity, and Solidity is a language that is meant to interact with the Ethereum virtual machine. And so there are several blockchains and layer 2 chains and side chains and all kinds of stuff which are quote unquote EVM compatible, so Ethereum virtual machine compatible. And what that essentially means is you can take this Solidity smart contract, change the environment, from test network to let's say XDAI is EVM compatible, or I think Arbitrum, Polygon, whatever, and you just copy paste it and deploy it there, and it would have the same, it would operate similarly according to the security features or parameters of that chain. So like a lot of the layer 2s have much lower gas fees, that sort of thing. But yeah, you could, if it's EVM compatible, that essentially means you can use the same Solidity code. But if it's not compatible, like if it's Solana or I don't know, Cosmos or whatever, then you have to use the language which has a compiler, which can compile it down to something readable by that blockchain. So not universally usable, but universal for EVM compatible blockchains.
Thank you.
Uh-huh. All right. I think with that, I'm going to stop sharing and stop recording. See if I can do that. Okay. All right. Where am I? There we go.